Hello everyone, my name is Mr. Miller and I am a high school Algebra 1 teacher. This video is mainly going to be used as an introduction to a lesson that students will take notes off of. It can also be used to help students review. This video will be covering mainly factoring polynomials. Alright, so this slide is here for you all to see what standards we'll be covering as well as the objectives we'll be going over. The first objective is the students will be able to completely factor various types of polynomials that do not require the quadratic equation. Then the students will be able to simplify and evaluate quadratic expressions completely. And lastly, students will be able to interpret various polynomials and assess which method of factoring they should apply based on their knowledge of the subject. There's only going to be two main concepts we're going to be going over in this video. There is many more ways to factor. The two we'll be going over is how to factor out a greatest common factor and then factoring basic trinomials. Alright, to begin, we'll start by going over what is a polynomial. A polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables. Now that we have that definition, let's look at subcategories of polynomials. First is a monomial, which is just an algebraic expression considering of one term. For example, x would be a monomial. Second, a binomial is an algebraic expression of the sum or difference of two terms. For example, x plus 2. Third, and the one we're going to discuss the most, is a trinomial. A trinomial is an algebraic expression consisting of three terms. For example, x squared plus x minus 3. Alright, so we're going to begin with the most basic type of factoring. This is factoring out a greatest common factor. It is likely that you've seen this before in previous classes, so we're only going to touch on it briefly. Alright, so let's start with the example 2x squared plus 4x plus 6. So looking at this example, you may notice that all three terms are divisible by 2. To take out a greatest common factor, you'll divide all the terms by the shared value of 2. This gives you the remainder as x squared plus 2x plus 3. Next, to show that you have divided all these values by 2, you will set up the expression like this, with 2 on the outside of a set of parentheses, and the remaining expression of x squared plus 2x plus 3 on the inside of the parentheses. Alright, so let's do another quick example. We have 12x squared plus 18x minus 24. Each value can be divided by 6, so let's write out our parentheses. We put the 6 on the outside here, and now we put the expression on the inside with each term having been divided by 6. So our final product looks like 6 times the quantity 2x squared plus 3x minus 4. You can always check your answers by multiplying everything back out. If it is equal to whatever your original expression was, then you're right. Alright, so next we're going to cover the basic factoring trinomial method. Let's begin with this very simple example of x squared plus 3x plus 2. First thing you want to do is write down two sets of parentheses next to each other like this. Since this problem is just x squared, and this term doesn't have a coefficient like 3x squared, since it's just x squared, you are going to put an x in each parentheses off to the left side like so. Next, to find the terms you're going to put on the right side of each of your parentheses, you need to look at your third term in your original expression. In this case, our term is 2. With this third term, you have to look at its possible factors. In this case of 2, our only possible factors are 2 times 1. Therefore, these are the two numbers we are going to put into our parentheses since we have no other choices to go off of. So once we put the 2 and 1 into the respective parentheses, we have to decide on the signs. This can be the most difficult part of factoring for students. When deciding your signs, you want to look at the signs from your original expression. So if your second sign from the original expression is positive, then the signs that go into your two parentheses are going to be the same. And the sign you choose to go into the parentheses will be whatever the first sign from the original expression is. So in this example, the second sign is positive, and since the first sign is also positive, then both of the parentheses will have this positive sign. If we were to change the original expression to x squared minus 3x plus 2, then in the end, the two signs in our parentheses would both be negative. So for our expression x squared plus 3x plus 2, our final answer is x plus 2 times x plus 1. To check our answer, we can now multiply our answer back out. So x plus 2 times x plus 1, we'll get x squared plus 2x plus x plus 2. And then we combine our like terms, we get x squared plus 3x plus 2. Moving on to our next example, we have x squared minus 3x minus 4. Since our first term is just x squared, we can start out our parentheses each with an x in them like so. Next, we look at our third term, which is a 4. We look at all the possible factors of 4, which are 4 times 1 and 2 times 2. Now, since we have two different sets of factors, you can either just guess and check to see which set works, or since we know our middle value here is 3x, you can look to see which set of factors, when added or subtracted together, could give us a value of 3. Here we see that 2 plus 2 nor 2 minus 2 gives us a value of 3. However, 4 minus 1 gives us 3. This way we know that 4 and 1 will be the values in our parentheses. Now we need to figure out what sign goes where. When your second sign in the original expression is negative, you automatically know that one sign in one parentheses will be positive and one will be negative. To decide which is which, you can generally base your decision off this rule. Whichever number in your parentheses is higher gets the same sign as the first sign in the original expression, and the lower number gets the opposite. Now this rule does not work for all problems, so be careful. You want to check your answer by multiplying your parentheses back out to make sure your signs are in the correct place. So in this example, since 4 is greater, its parentheses gets the same sign as the first in the expression, which is negative. And our second parentheses get a positive sign. So our final answer comes out to be x minus 4 times quantity x plus 1. Alright, our next step is to factor a trinomial that has an x squared value with a coefficient greater than 1. Our first example of this is 6x squared plus 5x minus 4. First thing to do is write out our two set of parentheses. Next we have to figure out what the two x values are going to be in our set of parentheses. We cannot just put two x's like we've been doing, because if we were to multiply back out, we would only get x squared and not the 6x squared we need. To find the values for our x's, we have to look at the factors of 6, exactly like how we've been doing when we looked at our third term. So the possible factors of 6 are 6 times 1 and 3 times 2. Here's where the guess and check method comes in most. With this method, what you have to do is simply do trial and error. So we start with the 6 times 1. We begin by putting in our 6x in one set of parentheses and our x in the other. Next we look at our third term, 4. We figure out the possible factors of 4, which are 2 times 2 and 4 times 1. Now we do trial and error. We go through each possible set of parentheses that can be made. So we have 6x plus or minus 2, x plus or minus 2. And then we have 6x plus or minus 4 times x plus or minus 1. And then we have 6x plus or minus 1 times x plus or minus 4. We're putting plus and minus in here because we don't know yet what our final signs are going to be with our parentheses, so we just put them in there as fillers. You next look to see if any of these combinations of numbers will work to give you the original expression. So one trick you can do here is you can eliminate the first two combinations just real quick. So you can eliminate 6x plus or minus 2 times x plus or minus 2 and the 6x plus or minus 4 times the x plus or minus 1. Because these two possibilities show that you have a GCF in the problem, where 6x plus or minus 2 has a GCF of 2, and the 6x plus or minus 4 has a greatest common factor of 2 also. Because of this greatest common factor being here, we can eliminate it because the original expression does not have a GCF. If it did, then we would be able to use these, but since it does not, we can't have a GCF later in the problem like this, so we can just eliminate these two. So now you're left to look at 6x plus or minus 1 and x plus or minus 4. Now let's see if when we multiply these numbers out, we can somehow get the middle term of 5x from the original expression. So multiplying these out, we are going to get our 6x squared, which is what we need. Next, for our middle terms, we get 24x and x. Then we get the 4 we need. Taking a look at the 24x and the x, is there any way adding or subtracting them together that you'll get a 5x? Obviously not. Therefore, this possible set of parentheses cannot be our answer. Since we now know that the 6 times 1 factor of 6 does not work, we now have to try the 3 times 2. So we set up our parentheses 3x with 2x, both on the left side of each parentheses. Now we look at our third term, 4. Its factors are still 2 times 2 and 4 times 1. So now we'll set up our possible sets of parentheses. We have 3x plus or minus 2 times the quantity 2x plus or minus 2. Then we have 3x plus or minus 4 times the quantity 2x plus or minus 1. And then we have the 3x plus or minus 1 times 2x plus or minus 4. We can now eliminate the first and third options because these show that they have a GCF when we know that there is not one from the original problem. Now we are left with our only option, 3x plus or minus 4 and 2x plus or minus 1. Now we have to decide on the signs. Since the third sign in the original expression is negative, that means one set of parentheses will be positive and the other will be negative. Alright, so as we said before in other examples, the larger number gets the same sign as the first one in the original expression and the smaller is opposite. However, we need to check to make sure we are putting our signs in the right place because of the greater coefficient on the first term. So to check, what we do is we multiply out 4 times 2x and 3x times 1. This gives you 8x and 3x, our middle terms if we were to multiply everything out again. Now you decide based on this which number deserves what sign. So we know the larger number is positive because we have a plus 5x in our original expression. Now we assign the positive or negative signs to our whole numbers, not our x values. So we'll be assigning positive or negative to our 4 and 1, not our 3x and 2x. So what we need is a positive 8x and a negative 3x. To get that, we'll need a positive 4 times positive 2x and a negative 1 times positive 3x. Therefore, we assign our signs as 3x plus 4 and 2x minus 1. Now if we want, we can multiply back out to check our answer. We get 3 times 2x for our 6x squared. We get our middle terms as positive 8x minus 3x. And we get our negative 4. Putting these together, we get 6x squared plus 5x minus 4, which is our original expression, which means our answer is correct. Okay, now we are going to go over an alternative method for factoring trinomials. This method is only useful when the coefficient on the x squared value is greater than 1. So let's look at our previous example of 6x squared plus 5x minus 4. To begin, we change the problem. We take the 6 and multiply it with our 4. This gives us the expression x squared plus 5x minus 24. Now we factor this expression, so we get x plus 8 times quantity x minus 3. Next, to change this so that we will get our original expression, what we do is we take the 6 that we originally moved and we divide the 8 and the 3 with the 6. This gives us the quantity x plus 8 over 6 times x minus 3 over 6. Next, we simplify the fractions. We get x plus 4 over 3 times x minus 1 over 2. Now we go bottoms up. We take the denominator of each fraction and move it in front of the x. Now we get 3x plus 4 times the quantity 2x minus 1 is our final answer, which we know from the previous example we did that is correct. Alright guys, I do hope this video has helped you all, and I would like to thank everyone for watching. If you have any questions, please feel free to email me at educjoshmiller@gmail.com. Thanks again.